Hi there. Today we're going to talk about the definition of a complex number. All right. So, complex numbers, that's the chapter, which is a very long chapter. So, let's talk about its definition, what a complex number is all about. So, definition. A complex number is a number which can be expressed in the form a plus bi, where a and b, where just write this down, a and b are real numbers, I is the imaginary unit which can be defined as or expressed as, it's going to be rather, I would say, defined as I square is equal to -1. So this is basically what a complex number is all about. And when we talk about complex numbers, now because we've mentioned that it is of the form a plus bi, so that could be, any complex number can take the form of z is equal to a plus bi, where we know that a is the real part. A is going to be the real part of the complex number, and also we have b, and b is the imaginary part of the complex number. Basically, now what happens is the real part and the imaginary part can describe a point in the complex plane as well. So we have this as the real part. The complex plane is made up of two axes, and the y or the x-axis takes the form of the real axis of the complex number z, and here we have the imaginary axis. And on the imaginary axis, of course, you're going to get numbers like I, 2i, 3i, 4i, and so on. Even for the negative part of the complex number, you can have negative numbers there. As for the real ones, you should be very familiar with it. We got 1, 2, 3, 4, and so on. Now, suppose we have a complex number. Let's say, let's take an example to be able to clearly understand. And now, before we go to the example itself, I'd like to talk about the real axis. As the name implies, explicitly, the real axis is the axis that represents all the real numbers, in the complex, in that complex number. And the imaginary axis would be the the y-axis, or the axis that represents all the imaginary numbers. We may have a complex number. Let's say, for example, z is equal to, let's say, 2 plus, say for instance, 3i. Now this describes a point in the complex plane. Therefore, if I were to look at a complex number, and in this particular example we have z is equal to 2 plus 3i, so I have 2 along the real part is 2 here, and the imaginary part is 3i, so 2 and then 3i will be somewhere over here. So I may call my complex number, let's say, p or z or whatever, even a for that matter. So here is my complex number, which is described as a point in the complex plane by the real part and the imaginary part. So that's all for today, because we just talked about the definition of a complex number. It's kind of a basic introduction to complex numbers. And of course, when we cover the chapter, we'll be explaining much more when it comes to complex numbers. For example, now we're going to be looking at addition and subtraction of complex numbers, multiplication, division, and so on. But for now, we're going to stick to the definition. You take care. Thank you for your attention.